So the point in doing this test review video is to go through and show you the right answers for all these problems. I don't want this to take more than really 15 minutes so that you actually watch the whole thing. So what I would suggest is if there's something that I go through briefly and you're not quite sure how to do it still, because this again is just like a check for you to see where you're at before the test, then make sure you start that problem and talk to me about it tomorrow before your test on Friday. Alright, so this should be your answer for number 1. And keep in mind that you can always pause this video too in case you need to write something down or adjust something. Again, you're just using synthetic division to break it down and then solving it the rest of the way. I chose to use factoring here. You could have used the quadratic formula. That would have been fine. For number 2, that's the answer that you should have gotten for your other 2 intercepts. I found -5 as it was the one whole number 0 that I could have used to break down the polynomial further, and explain in a few sentences how I found the first 0. I graphed this function, used the standard window, and then looked to see where it crossed the x-axis and used the 0 feature of my calculator to find that. Excuse me. Okay, flipping. For number 3, you have 3 similar problems here. All of these are the proficiency type problems you would have to be able to solve. So in each case, we're isolating the radical first. So here I isolate the square root, move the 4 over, divide by 2, and then square both sides to solve. Now, I didn't do this part, but it is your job to actually check those answers in the regular equation to see if it works. This one does work. And this one does too. So when we solve this one, it's a cube root function. So again, we isolate the cube root, we add the 18, we divide by 2, and then you cube both sides and solve for x. For C, because you're supposed to do this to simple story problems, gives you this function and then tells you a b value of 7. So I have to take this 7, plug it in for b, and since I'm working with decimals, I can keep working with decimals. So I add 3.49, then divide by 1.69, and then to solve for s, the speed, which is what I'm looking for, I square both sides, which gives me this. Then I subtract 4.45 to get that as my mile per hour speed. For number 4, that is the equation that we end up getting. It's working out. We've done several of these. I do keep it in fraction form here, so you have -69 over 16, square of the top and the bottom to get that answer at the end. I did also ask you to define extraneous solutions in your own words. An extraneous solution, well, it'd have to be in your own words, but it's basically an extra solution that introduces itself when you start squaring both sides of an equation, or if you were to fourth both sides of an equation. That's why we have to check our answers, because sometimes when you do that, it introduces a false solution and that number wouldn't actually work out. This one, when I plugged it back in, did not actually work out. So this is an extraneous one, which means if we were to graph both of these functions, they wouldn't actually ever intersect because it doesn't have a solution. Okay, flip. These are the 3 type of problems that you'll have to be able to do. For A, that's just subtracting like terms. That's the answer that you should get. For B, we're foiling and then adding like terms. And for C and D, you're forming compositions. So this is plugging 2x minus 1 in for x in both places. And then I simplified. So I FOILed that out, because that means 2x minus 1 times itself, which would give you this. And I distributed the 4 through, distributed the -4 through there, and then I added my like terms to get that expression at the end. For D, same type of thing, except now we're plugging f of x, so this whole thing goes in for x here. Now when I simplify, that 1/2 goes to the 4 and to the x to the 2/3. When you have a power and a power, you multiply. That's where I got the 1/3. 4 to the 1/2, that's the same thing as saying the square root of 4. So that's how I was able to, because remember that's index over power, or excuse me, power over index. So your index is the square root. That's how I got that 2 to be there. So your final answer should be -4x to the 1/3. Okay, flip. still F1 problems. These are 4-type problems. You're given a scenario here, and then you're supposed to find an equation by using composition that represents height and footprint length. So I'm plugging this function in to this function for L. And so I should draw an arrow here. So where L was, where length was, I input the footprint equation. So I get this. And then it tells me to find the height given a footprint length of 30. So then I plug 30 in for F and punch it out to get that as my height. For number 7, A and B, those are the answers that I got. This one might be a little bit different. You could make this. Actually, it would have to be that. And that one's more straightforward. Okay, flip. For 8, A and B, those are the answers that you should get. I would accept either one of those. This is just 2 different versions. Like 1 divided by 6 gives you 1/6. 8 divided by 6 gives you 4/3. You can write it either way. Just make sure that you write it with the inverse function notation. And then for this one, that's what you should have gotten for that. For the F2 type 4 problem, essentially what you're doing here is you're trying to write it as a function of its volume, which means I want t equal to something with v in it. So I need to solve for t. So in this equation, I'm not going to flip-flop variables here. I'm just going to get t by itself. So I move this over by dividing it. That's just a number in science function notation. What's that called? Scientific notation. Oh my goodness. Scientific notation. And then you cube root both sides, so you get t by itself. That's fine as your function. And then it tells you to find its volume, or find its age given its volume. And so we plug that volume into V and punch it out, and you end up getting that as your years. Okay, flip. 2 more to go through. For 10, A and B, those are the 2 graphs that you should get. Again, pause it if you need time to really check it out. Then for 11, that's what you should get. You're also asked to describe for the square root function why mathematically the domain and range are the way they are. You can talk about the fact that the square root function is the opposite, like that's the square root function. It is the opposite or the inverse of a squared function, a quadratic. And with inverse functions, they flip. Their graphs flip. We can't have that whole graph flip because then it wouldn't pass the VLT, so that's why we have one branch of it there. And because we only have one branch of it there, your x's are going to be affected, so you're not going to have some x's represented, and you're not going to have some y's represented. So your domain, mathematically, would have to be x greater than something, and your range also y greater than something. Also, you can't take the square root of a negative number and be able to plot it. So that's the other reason why domain and range for a square root function, neither of them are all reals. Now, looking at this without graphing, I know this has shifted to the right 4, and this has shifted up 2. So if I know the general curve looks like that, and if I shift it over 4, that means that this point then is going to be at x4. X is 4, so the whole graph is going to be x values greater than 4. And then if I've shifted this up from the origin, then that's going to be shifted up y values greater than or equal to 2. So you should be able to do that without graphing. Okay, and then flip, last one. For 12, you're supposed to solve this algebraically. Solution mean in terms of the graph. This is the intersection point. Set them equal to each other, moved everything over to set equal to 0, and you could have factored, or in this case I used the quadratic formula, but those are your 2 intersection points. Then for 13, this one is solving with a calculator, so you end up getting that solution, and this is graphing it, so graphing both sides, and then finding the intersect feature. And maybe we just need a quick little review on that. Okay, so if you were to graph that, 8x cubed plus 4x minus 1, and then is equal to the square root of 6x minus 1. I went to a standard window. then I can see they intersect in my window, so I'm going to go to the Calc menu, which is second trace, and go to the intersect. First curve automatically selects. I might have to move over a little bit on the square root function to get it to select. Hit one more time, and then you end up getting 0.413. For 14, same type of deal, except you have to decide off the bat which way to do it. And you have to be able to explain how you knew you could do it with a calculator or without. In this case, you could have used algebra, but the reason I would go calculator on this one is because if we were to square both sides, this would end up being a quartic, and so it's not easily solved using algebra. So that would be the reasoning that I would need to hear from you, is that you've thought through, okay, if I solved it algebraically, this is what I would have to do, but it would make it a quartic, so that would be too difficult to do easily. Like, you could do it, but it's too difficult to do easily by hand, so that's why I went with a calculator. Okay, so, wishy-washy answers are not going to be okay here. I have to know that you actually thought through the process and made a good decision based on like where it was going to go. So maybe you decide, okay, I'm just going to try it all right off the bat by doing it algebraically, and then if I run into an issue like this one, then that's where I use the calculator. And I have to be able to explain why I went calculator instead of algebra. Okay, make sure that if you've marked anything down, you come talk to me tomorrow before your test on Friday.